like to talk to you today about our work on national water resources modelling, and really how we've been initially starting to use a suite of tools that were set up more for an academic research purpose, but we started to bring those in-house, and we're using them more to support our evidence-based decision-making as a set of regulators. So the work that I'll present on today, it's not just Environment Agency, it's also RAPID. RAPID, another acronym, is Regulatory Alliance for Progressing Infrastructure Development. And RAPID is made up of Drinking Water Inspectorates, Ofwat, and also the Environment Agency, so the regulators for water quality, cost and financial side of things, and the environment across the water sector. In terms of the content, what I'd like to run through today, just give a bit of background, realise everyone in the room might not be entirely familiar with the policy and the regulation landscape around water, so I just want to set the scene with that, and then move on a little bit more specifically to discuss our national system simulation modelling project, then broaden back out and cover off a little bit on our national water resources modelling tools, and then finally get back to kind of future plans and how we plan to use more of the Daphne platform for water resource modelling in the future. So starting off with the background, around 7 or 8 years ago, there's quite a stepwise change in the awareness of the industry around the challenges that we were starting to face as a sector, and also how policy was reacting kind of commensurately to those challenges. So this really started around 2018 with the NIC report, Preparing for a Drier Future, possibly a little bit earlier. There's a 2016 report from Water UK. The NIC report was quite important because it kind of set out a long-term view on the pressures and the multitude of different pressures that water resources faces nationally, and it also made 2 key recommendations. One was to halve leakage by 2050, and the second was to improve the national drought resilience from a 1 in 200 level to a 1 in 500 level by 2030. So slightly following on from that, water companies industry started to pick up more on some of those challenges in these reports, and with that in mind started to think a little bit more strategically around supply options and the need for interventions to increase the amount of water that's available for supply to meet some of these needs. And that was reflected in the PR19 document and also the funding that was put forward from Ofwat to kind of fund some of those options. Slightly later, in March of 2020, we had the National Framework for Water Resources, which is an EA-led project that really kind of quantified those future water needs, set the size of the challenge for this kind of subsequent planning rounds, which is the round that we've just been through, WMP 24, and also endorsed the same two recommendations that the NIC had put forward. Just toward the end of 2020, both those recommendations were actually made statutory, so the government took them forward and included them in National Infrastructure Strategy documents. So hopefully, just from that summary, you can see in the short space of 2 or so years, there's kind of growing awareness of challenge, and then start to be quite a significant step up in terms of our reaction at the policy level as well. Water companies also changed their approach to planning throughout that process. So back in WMP 2019, if you look at the bottom of the left of the slide here, you can see the 16 or 15 water companies that cover England and Wales. And regulators wrote to the water companies around the same time as the national framework and asked for them to think a bit more strategically in their planning. And the response from water companies was to join together into these kind of water resources planning regions. That's what's shown on the middle map on the slide here. So there's 5 regions: the north, east, west, southeast, and the West Country. And what these regions do is allow water companies to kind of plan more strategically, share their assets on a kind of regional basis. And it also allows more creative thinking and innovation around national scale options, because we just have to think about the interoperability of 5 regional plans rather than 15 or 16 individual water company plans. That's an easier problem or conversation to have. Just after the publication of the national framework, we also had the creation of RAPID, so Regulators Alliance for Progressing Infrastructure Development, and the National Appraisal Unit, which is the team that my modelling team sits in the Environment Agency. And the remit of both of our teams, or the focus of the NAU and RAPID, is really around the strategic resource options. So those are really big new infrastructure water supply options. and things like you might have heard of before, such as SESRO, which is South East Strategic Reservoir Option, which is mentioned by the keynote this morning. There's other options in there, so there's things like water transfers as well, but the remit of RAPID and NAU is to try and progress the development of those options. So just a bit of background to RAPID. They originally started out with around a £500 million pot of money, and that was set aside by Ofwat to help water companies progress the development of around 18 options originally, including things like SESRO and Severn to Thames transfer. The way that RAPID worked is through a gated scheme, a gated process, and the idea is that through the milestones that are shown on the timeline on the bottom right, that if water companies met certain criteria at certain times, then additional funding became available, and those schemes were kind of developed and progressed. The idea is that we're trying to get some of these nationally significant infrastructure projects construction ready and operational by 2025, 2030 periods, just to meet those kind of growing needs around water. So subsequent to creation of RAPID and national framework, there's been a few more years have elapsed, and in that space there's been more of an evolution around both the challenge and the reaction in the policy space. Earlier this year, in the summer, there's the publication of the refresh of the national framework. Some of the headline numbers for that are quite important. So the national water needs across England are now around 4,940 megalitres a day, which is quite a significant increase over the first national framework. So we're looking at an uplift of around 1,500 megalitres a day of water that's needed nationally at 2050. So that's quite a big growth over 5 years of just that additional need. And in reaction to that, again, in the latest round of the price review, so PR24, more funding's been put forward to help develop more solutions. There's now £2.4 billion worth of funding for the development of SROs in PR24, and there's 17 new strategic infrastructure projects that are being considered as part of PR24, 11 of which are new SROs that are being looked at under the RAPID gated process. So RAPID in itself has also grown in remit alongside those challenges. So back in 2019, it looked like the spatial coverage of the options looked like the map with the grey background, and now in PR24, it looks like the map with the green background. So you can see there's not only more options, but they've got a greater geographical spread. So we're really starting to look at kind of a national scale set of options to meet or kind of water needs, and really quite big strategic options to meet those needs as well. And the money behind that has also increased quite significantly. So that programme of options is now looking around the £50 billion worth of investment total. So what does all this mean as regulators? It means that we've got quite a lot of future challenges that water companies are planning against. It means that we've got a set of options that are being put forward, and we've got to make decisions on those in quite a short time scale. We don't want to make the wrong decisions around them as well. And what that boils down to is the kind of age-old process of trade-off, which is kind of intrinsic to the water resources planning problem, and that you can kind of represent it as a trilemma, which is shown here on the slide. But there's that trade-off between affordability to making sure that water company plans and the options are affordable for bill payers, they represent good value for money, so that's the remit of Ofwat, making sure that whatever interventions that we put into play don't damage the environment or ideally would improve the environment, so that's the remit of the environmental regulator. And then we've also got the security of supply aspect as well, and that's the idea of making sure that obviously there's enough water in taps and that the supply network is resilient to pressures like climate change, population growth, leakage, growing demands. So ideally we'd have a model that did all of that in one, some kind of holistic approach, but we're not there yet. That's part of our long-term goal. I guess where we are and where we started off was focusing on the security of supply aspect and starting to look at independently testing whether we agree at a national level whether the drought resilience benefits associated with strategic resource options that water companies are telling us about, whether we agree with that and whether the right mix of options are being chosen. And that leads on nicely to the National System Simulation Modelling Project. So this is a joint project between Rapid, Environment Agency and academia as well. So Jim Hall and his research group at University of Oxford and Anna Murgatroyd has been quite heavily involved in that project, who's with us today. And also involves the University of Bristol, who supported on hydrological modelling. So the system simulation model, as the name suggests, is a kind of digital representation of reality. So it includes things like reservoirs, water treatment works, all the river systems, groundwater abstraction. And it's a simple resource allocation problem. So it's trying to effectively minimise the cost of transferring water around the network whilst also meeting demands. So the project has a few aims, technical aims. There's three of those. The first is to independently assess the strategic resource options, and by that I mean testing the resilience of the SROs against nationally coherent droughts, so big, large-scale droughts, and climate change impacts, just to make sure that we think they're resilient, that these options can stand up to the range of uncertainty of climate change pressures in the future. We also want to sense check that the emerging regional plans are kind of robust by stress testing these options, so making sure they can stand up to a range of possible futures, and ultimately use the outputs from the model to support our decision making around the selection of supply options and kind of influence the ones that are being chosen. In the long term, we ideally want to get back to this kind of trilemma and develop an integrated modelling approach that accounts for cost, water quality, the environment, and kind of explore all those trade-offs within one framework, if not one model. But that's a future problem. It's just one of our kind of more strategic goals, if you like. It's probably worth mentioning as well at this stage that what I'm describing probably sounds quite similar to water company modelling, and the idea is that we're not trying to replace that at a national level. The national model is just a top-down approach. It's a different way of looking at the problem, and the idea is that it would be kind of complementary to the water company modelling. It's just looking at things through a slightly different lens, if you will. So there's been three phases of the modelling. We had phase one, which is initial proof of concept. That was really just putting the SROs into the model, which was originally this kind of more academic research-based tool. Phase two is a little bit more ambitious in terms of looking at combinations of strategic resource options and also exploring a full range of uncertainty of different scenarios. And phase three, which is the most recent phase, is actually really around kind of recreating the water company management plans and their scenarios in our model and testing them to make sure that we agree with them. So that's our national system simulation model, which is shown in the box in the blue on the right here. But we also have some other modelling tools that are available to us as regulators. And we've got this set of models that we've branded aggregate models. So what those are is they're a little bit different. They're not a system simulation model. They're based on water company planning data. So they're based on the outputs from water company models that are supplied as part of the planning process. And what we've done is combined, if you like, or aggregated together that data to give us a national view. And these models are the models that kind of support our long-term strategic view on water resources. They evidence things like the National Framework project that I mentioned earlier. So we've got two components to this. We've got the one on the left, 1A, which is the supply-demand balance model that effectively figures out surplus and deficit in the future. So the size of the problem, if you like. And then we've got 1B, which effectively tries to solve that problem. So it's a supply system optimizer. It has access to the full range of supply interventions that WMPs have access to, and a range of hypothetical new transfers that connect up different parts of the country. And the idea there is that that model can try and find least cost or most cost efficient sets of options to meet those water needs. So it's quite similar to supply-demand balance modelling and EBSD modelling that water companies carry out, albeit at a slightly more abstracted and national scale. So hopefully that's quite a bit of background and the tools that we've got. I guess bringing it back into reality and what we actually do with these tools. So for the aggregate modelling, the one that I just mentioned, we use that to define the planning problem and the challenge by quantifying how much water is needed nationally under a range of different kind of plausible future scenarios of water needs and pressures. We also use the optimizer to identify new options for meeting water demands. So asking questions like, are there new large-scale options that could help us meet water needs more efficiently than the options that are currently considered in WRMPs? And the system simulation modelling is that independent assurance on whether the options considered by water companies are the correct ones. So answering questions like, do the SROs provide the benefits that are presented in the WRMPs? Does the performance of SROs change when they're tested against national scale droughts rather than the more specific droughts that are sampled by the water company methods? And are the right combinations of options chosen? So lastly, on this bit, the other thing that we can do with these models is to look at the consequences of delays to delivery to SROs. So at the moment, the current SRO milestones and timelines is quite ambitious, and it's what's summarised in the slide here. So the blue represents the kind of scoping and the development of the SROs, the grey is the construction, the green is the time when they're all going to be operational. Won't go into the detail here, but you can see that a lot of the timing coincides, basically. So there is an elephant in the room, the question of, can we deliver all these things at once? Probably not. Something's going to give, and yeah, we need to explore and understand what that looks like. So we can use our tools to try and figure out which delays carry the greatest impact and risk, and therefore we can look to kind of ameliorate some of those risks and kind of progress those schemes or make sure they don't get delayed. And we can also use the tools to assess whether there's insufficient options to mitigate delays, and could new alternative national options help plug the gap. I just want to cover now, I guess, some of our future plans for how we want to utilise Daphne and our water resource modelling tools. The first obvious thing to do is to build our tools into a bit more of a framework. And that's what's shown on the slide here, trying to leverage the strength of each approach. So we'd have at the bottom, the foundation, if you like, would be the supply-demand balance model, and that would give us the size of the problem. Then we'd have 1B, which is the options optimizer. That would explore robust optimization, so sets of options that we think meet a range of different water need scenarios. And then we'd have the detailed stress tester, if you like, the system simulation model that would sit on top of that and really do the due diligence around and testing the uncertainty and the robustness of those options. At the moment, only the system simulation model is on Daphne. We've got some discussions around deploying the other two models, the aggregate models. So another thing that we want to do is also focus a little bit more on stakeholder engagement through interactive visualization. And yeah, Emily Fallon, you may have picked up on her presentation downstairs on this, so I won't dwell on this too much. But the first national framework had quite a lot of standalone documents and figures. It's quite difficult to access the data. So for the second national framework, we've developed an interactive dashboard where users can kind of go in, look at the results, explore them, probe them, and also download all the data as well. And the idea is to potentially deploy this again on the Daphne system. So it's making those insights more accessible for a broader range of stakeholders through the system. Another area is collaborating more with Ivana Murgatroyd, who's been working a little bit more on RU, which is another name for the system simulation model. And Anna's been doing some great work on migrating the model from WathNet, which is the software that it currently uses, over to Piware, which is just a much more flexible and kind of open source platform that's being used more readily across industry. So it makes sense for us to migrate the model wholesale and collaborate more with Anna and on the Daphne platform around that. And then the final area is just some work we've been doing with University of Sheffield using their SITCOM, so the Causal Inference for Testing Computational Model framework. And what this boils down to is that models are quite complex, and it's quite difficult to understand whether the results that we're getting out of them are actually meaningful, or whether they're kind of being controlled by things like non-convergence of optimization or instability. And that's what we can kind of robustly assess through this framework. So yeah, doing more work with Neil Wilkinshaw and Michael Foster on that. And the final slide from me is just around the future of water regulation and how modelling fits into that. So you probably picked up on the IWC report that was published earlier this summer, the Cunliffe report. There's a lot of recommendations that have been made through that, and it's unclear where it's going to go. But the main ones that I've pulled out that are probably relevant to modelling are the expansion of the RAPID programme. So that means more work for testing the options, focus on long-term water needs, which is more work on the national framework modelling, consistency of methods, which is kind of what we're doing through the national modelling anyway, and the integrated piece, the integrated regulation is probably the biggest bit. There's probably quite a lot of opportunity there for building a integrated model that covers water quality, environment, cost, resilience. So I think this really sets the narrative of what we need to do, and hopefully modelling is quite intrinsic and central to that. So I'll stop there.